3 on nail theory, nail anatomy and physiology by Trieu, London. So in the previous video, we went over the structure of the nail, and in today's video, we'll be going over bones and muscular system. This is quite a big topic in terms of the series, and so be ready to learn new concepts and new terms and what each bone and muscle does. So let's start. The hand and arm are made up of 30 bones, from the top of the bone, top of the arm, to right down to the fingertips. So in the hand, we have the following bones. So we have the trapezium, the scaphoid, the lunate, the pisiform, the trapeze, the capitate, the hamate, to triquetrum, metacarpals, and phalanges. So I'll put down spelling for some of these. So trapezium is quite easy to pronounce. Forward. This one, the pisiform, so pi. Form. This is almost like hey, mate. And this one could pronounce tree or tri. Drum. And metacarpals, phalanges. So let's actually see what that looks like on the hand. I've labeled, so if you do take down this list, take it in this ordered number, and you'll see that on the hand, I've actually labeled the relevant bones with the numbers relating to them. So most of them bones are here, just near the wrist. We'll go into the bones in the arm, which I've just labeled here so you can see in what way they actually connect. And in terms of phalanges, you don't need to know the breakdown of proximal, distal phalanges. You just need to know that they are called phalanges, and the metacarpal bones are this, just in your palm. In terms of the phalanges, the way you distinguish between your fingers and your thumb is just that your thumb actually only has 2 phalanges, whereas the rest of them have 3. So the wrist consists of 8 carpal bones that glide over one another to allow movement called a condyloid or gliding movement. So that's these bones here. 5 metacarpal bones make up the palm of the hand. So that's these here. And 14 individual phalange bones make up the fingers. So 2 in each palm, 3 in each fingers. So take a moment to pause, maybe copy this down or annotate your own diagram, which you might have in front of you. We then have the bones in the arm. So we're looking at the forearm mainly. So we've got the radius and the ulna. So radius is the thicker version, the thicker bone, and the ulna tends to be the thinner bone in your forearm. And then you have the elbow here and the humerus, which is the bone connecting to your shoulder. You then have the thumb and the wrist bones here. So your arm bones are made up of 3 long bones. The humerus is the bone on the upper arm of the shoulder to the elbow. Then you have the radius and ulna lying side by side in the lower arm from the elbow to the wrist. Having 2 bones in the lower arm makes it easier for your wrist to rotate. And the movement causes the palm to face downwards is called pronation. And the movement that causes it to face upwards is called supination. So maybe worth noting. Upwards, so color is supination. Okay, so joints make up the engineering of the hands and produce a variety of movements, making everyday tasks possible. Joints are wherever 2 bones come into contact, so that's important to note. So what are joints? They're wherever 2 bones come into contact. Bones are bound by ligaments, which limit their movement to prevent dislocation. So bones are bound by ligaments. That means the range of motions is prevented to prevent dislocation. Now, the power behind the joint movements is supplied by muscles. At each end of the muscle is attached by a strong tendon to the bone. So your muscle is actually attached to your bone by a strong tendon. At one end is the insert origin, and the other end is insertion. So where you have the muscle, you have one part which is origin, the rest is the insertion. So muscles are most powerful at the point of insertion, and when movements occur, they are a result of the muscle contracting and pulling one bone to another. Muscle bones need a good supply of blood to stay healthy. They also need protecting from external damage by skin, which is structured especially to withstand friction and pressure. There are a range of different joints, and I'll give you an idea of what the range of movements occur within them. So you have the small bones of the phalanges that move at hinge joints. So let's highlight that. And it's limited to one direction only. So one direction. You then have saddle joints, such as the thumb connected to the hand. A different color, orange. And it allows it to rotate freely across the palm. This movement is known as opposition. Without this, our hands will just be a claw and we won't be able to grip anything. Then there's individual pebble-like bones of the wrist that just glide one over, mainly sideways. So there are some disorders in the joints. One of them's rheumatism, and it's basically a general term for pain. It just means pain, with or without stiffness, which affects the muscles and joints. It's described as a common symptom of a disorder rather than being a disorder itself. So it's just a symptom of a disorder, and covers many conditions, including arthritis, which we'll now go into. So, arthritis. So arthritis is a general term for inflammation of the joint, and the condition can follow injury or bacterial infection, but more commonly it is a result of wear and tear. And that's why it's usually more common in older people. So the joint swells, stiffens, becomes painful, and the overlying skin can become red and shiny in appearance. In severe conditions, the whole hand can appear to be deformed. Now we go into the muscular system. So muscles are responsible for movement on the body. They're made up of a bundle of fibers bound together in a sheath, the fascia. Muscle tissue contracts and produces movement. So when your muscles actually produce movement, it shortens and contracts, and your muscles actually never completely relax. As mentioned before, it's anchored by a strong tendon to the bone, and the point of attachment is known as the origin, and the other point is insertion. So the muscles are likewise joined to a second bone. The attachment in this case is called insertion, muscles insertion. So it's usually attached to, the main point here is it's usually anchored to one strong tendon bone, which is the origin, and the muscle are likewise joined to a second bone, and the attachment is called the muscles insertion. It's the second bone that is moved. The muscle contracts, pulling the two bones together. So that's quite an important note. And different muscles on the other side has the contrary effect. So when one muscle tenses, the other relaxes. So for example, biceps and triceps. Not all muscles are attached to the bone. Some insert into another muscle or into the skin itself. Now, properties of muscle tissue. One, it can contract, shorten, is extensible. So when a extensor muscle in a joint contracts, the corresponding will flex. So we mentioned earlier the bicep and tricep. So if you tense in your bicep, your tricep will relax. If you tense your tricep, your bicep will relax. So we're talking about the upper body of the arm. It's elastic, so it usually returns to its original length after contraction, and it's responsive. So it responds from a nerve stimulation. This point is again reiterated here. So voluntary muscles contract only when stimulated by a nerve supply. It requires energy, and this is supplied by tissue respiration taking place inside the muscle cells. In this reaction, glucose, which is sugar, and oxygen are used to supply energy. and then carbon dioxide and water are released as waste products. Muscles need a good supply of oxygen and glucose when a person is exercising and to carry waste. So we're going to go into a diagram of the muscles of the hand. There are, again, a few more weird terms we're going to be looking at. So let's have a look. I will try write them out for you as well. So the first one is opponens pollicis. So I'll write that out again. So it's oppo, then nens, space, and poly, and cis. The second muscle in the hand is the opponens digiti minimi. So let me write that actually. So it's the same thing, opponens like here, but I'll write out digiti minimi. So D, D, T, then mini, mi. You'll notice that some of these words repeat again in the following muscles. So once you know it once, you'll know how to pronounce it for the rest of them. So then we have this muscle here. The key difference here I'm going to highlight just because you can see later and go down is the abductor digiti minimi brevis. So brevis is just literally just brave and this. So we know we spelled digiti here and minimi here, and then brevis is just there. We then have the flexor digiti minimi brevis, the flexor pollicis brevis, and now we have the adductor. So not ab, but ad. So it's slightly different. Adductor pollicis brevis, the abductor pollicis, and the lumbricals muscles. We're going to relate to why how abductor and adductor is different. So bear with me. So again, if you want, you can write out this list of muscles in the hand, and then in this diagram, feel free to pause it, draw it, or take a picture, print it out, and put in your notes. Or if you already have notes, then label this. So I put all the numbers besides the muscles. So, and they specifically relate to these specific muscles. So in your thumb, you have these three almost layers. The opponens pollicis is actually this bottom layer of the thumb. The abductor pollicis brevis is the middle, and the flexor pollicis brevis is this part here. The adductor pollicis is almost the muscle in between your thumb and index fingers, and the lumbrical callus muscles are all here. So they are as they show, and they specifically point in specific parts of the muscles of the hand. So please remember that. Please take note of the list and pause the video if you need to digest this. We then go on to the diagram of muscles in the arm. So firstly, there's a division line between the dorsal and ventral compartments. You just need to remember the division line. We have the extensor digitorum, so almost like the digiti mentioned before. The extensor carpi ulnaris, the extensor carpi radialis brevis. So we mentioned brevis before, but I'll write out radialis. So it's almost ray, the this. So carpi radialis brevis. We then have the extensor carpi radialis longus. This one's quite a tricky word, so I'll write this out. Just brachii, and then radialis. Brachioradialis. Okay. And then you have the lateral epicondyle of the humerus. I'll write out epicondyle anyway, so it's epicon, and then dial as in dilaphone. So tricky ones probably brachioradialis and epicondyle. So let's see what these muscles actually look like. Again, I've listed down numbers with the muscles in the arm, so do note this down. So when we look to the diagram, it makes sense. In this diagram, there are a few different muscles that are listed more. It might be worth your course or not, so be aware depending on your course. But as I said, I've mentioned the numbers. So division line, and it exactly pinpoints to each specific muscle strand in the arm. And all these numbers are related to the specific muscle and where they lie. So take a good note. I'll zoom in a bit so you can actually pause the video and see where they actually lie. And we'll move on now swiftly. This is just a slightly larger version. So we're going to go through what each of the muscles in the arm and hand are for, what they do, and their action. So muscles work in pairs to produce movements at joints. Muscles are made up of fibers and always pull in one direction of the muscle fibers. So you have the flexors, bend the parts they're attached to, the extensors, straighten the parts they're attached to. So they remember they work together, flexors and extensors. And remember I went through and I highlighted abductors and adductors. So we're going to go through why they're different. So abductor, highlight a different color. So abductor pulls away from the center of the body. Adductors pull parts towards the center of the body. So the hand and fingers are moved primarily by muscles and tendons in the forearm. These muscles contract, pulling the tendons and thereby moving the fingers, much like a puppet is moved by a string. The muscles that bend on the wrist, drawing it towards the forearms, are flexors. Other muscles are extensors, and these straighten the wrist and hand. So we can probably highlight a few things. So the muscles that bend the wrist, drawing it towards the forearm, are flexors. Other muscles are extensors and straighten the wrist and hand. So these are upper muscles within the arm. So we mentioned all the muscles earlier before here in the arm. So let's see what they actually do. So again, here's the big word brachioradialis. Let's go through. So it's on the outer thumb of the forearm, flexes and turns the elbow. You then have the flexor carpi radialis, which is in the middle of the forearm, and it flexes and abducts the wrist joint. Then have the extensor carpi radialis, the longest and the bravest, thumb side of the forearm, extends the muscles and straightens the wrist and hand. You have the flexor carpi ulnaris, so it's the front of the forearm, and a different color. Just at the front of the forearm, and muscles that flex and adducts the wrist joint. Then you have the extensor carpi ulnaris, which is the back of the forearm, and extends and adducts the wrist. You have the palmary longus, which is the middle of the front of the forearm. It flexes and at the wrist and hands. You then have the hypothena muscle. So if you want to write that down, it's hypo and phi, then F-E-E, na, that's how you pronounce it. It's in the palm of the hand, below the little finger. It flexes and moves it towards and inwards. You then have the phena muscle in the palm of the hand, below the thumb. So this one is hypothena muscle, which is below the little finger, whereas this one's below the thumb. And it flexes the thumb, moves it outwards and inwards. The flexor digitorum tendons, front of the fingers, flexes the fingers when they're contracted, and the extensor digitorum is the back of the fingers, extends the fingers when contracted. So that's all the muscle types in the hand and arm. We then move on to the fluids of the body. Again, if I'm going too fast, do pause the video because there is a lot to take in, and remember to digest some of this. Depending on your course, you will need to know different types of movements, if it's adducts, abducts, flexors, or extensors. But this is based on the difficulty of your course and the requirements of your course. So we have fluids of the body. So there's three main fluids. You've got blood, tissue fluid, and lymph. But we mainly focus on blood here, and we'll go through tissue fluid in small bits, and then we'll have a whole topic maybe. Well, we'll go over lymph in this section, but there will be a whole topic on the lymphatic system in another video in this series. So blood circulates through blood vessels. So you have three. You have the arteries, the capillaries, and the veins. They collect oxygen from the lungs and deliver it to the cells of the body. Glucose is also carried in the blood and used by the cells together with oxygen to supply energy. So blood also supplies the raw materials to build and maintain cells, or to manufacture products such as secretions. So inside the tissues, some fluid leaks do occur from the capillaries and passes as blood passes through them. So this is the fluid that actually then becomes tissue fluid. So that's how blood and tissue fluid link. So let's talk about blood supply to the hands. So all living cells need oxygen. So that's all around our bodies. The arteries carry blood, which contains oxygen, bound by a chemical called hemoglobin. Blood containing oxygen is bright red. So it's good to know. And it also contains a breakdown of product digestion, which basically is nutrients, which are carried to the living cells to keep them healthy. When the cells have actually taken up the oxygen from the blood and used up the nutrients, they create waste products, which are then taken away by the veins with carbon dioxide. So it's in your hands, the blood with oxygen and nutrients is brought to you by the arteries, and it's taken away by the waste, and the carbon dioxide is taken away by the veins. Blood which has had its oxygen removed by cells is blush in color. Capillaries form a branch of network of tiny, thin-walled vessels that link the arteries, tissues, and veins and circulate blood around the body. Now, arteries of the arm and hand. The arm and hand are nourished by system of arteries that carry blood to the tissues. The brachial artery, so that's how you pronounce it, so it's almost like break and then eel, supplies blood to the upper arm. This branches into the ulnar and radial artery, which supplies the forearm and fingers. The radial and ulnar arteries are connected across the palm by a superficial and deep palmar arch. So you've got the two arteries in the forearm, which are then connected by a superficial and a deep palmar arch. These arteries divide to form the metacarpal digital arteries, which supply the palm and fingers. So there's quite a few arteries that are listed here, and I've decided to list them here. So you've got arteries of the hand. Again, these are numbered for a specific reason, because on the diagram they'll have the corresponding numbers. So we've got the radial artery, the ulnar artery, the deep palmar arch and superficial palmar arteries, which are again in the palm, the common digital arteries, the metacarpal arteries, and the deep branches of metacarpal arteries. Of course, this goes from the arm down to the wrist and hands. So let's see what that looks like. So we've got the radial artery near the radius bone, and then we have the ulnar artery near the ulnar bone, covering like so. We've got the deep arch, which is just a small arch, and the superficial palmar arch, which is a big one. And you have the common digital arteries, which are small veins going into the fingers and thumbs. Then have the arteries of the arm, so the brachial artery, the radial artery, the ulnar artery. So radial artery and ulnar artery, as shown here, and the axillary artery. So the brachial artery is this part here, and then it switches into the radial and ulnar arteries, which are these two here, and then you have the axillary artery on the upper arm. So veins. Veins deliver deoxygenated blood back to the heart. Blood with oxygen removed appears blue. So we mentioned that blood with oxygen appears red. If it's without oxygen, it's blue. Veins often pass through muscles. Each time muscles are contracted, veins are squeezed and the blood is pushed along. Massage is therefore particularly beneficial in this process. Rather than the digital veins draw blood from the fingers, the dorsal arch drains blood from the hands, and the cephalic and basilica veins drain blood from the forearm. So there's a lot to take in terms of muscles, the veins, the bones, structures in the arm. The next video will be on skin types and skin structures, so it should be less technical than this specific video. Again, pause where you think it's gone too fast. Take note of the diagrams of the specific bones, the specific muscles within your arms and hands, and really take time to digest it. Also learn to pronounce the words correctly and what an extensor and flexor abductor and adductor do. So I hope you found this information useful. I know it's quite a lot to digest, but in due time you should be comfortable with it. And I look forward to seeing you in the next video where we will be going over skin types and skin structures. So that's bones and muscular system done. Thank you for watching. Please comment, subscribe, like, and I'll see you next time.